subject data communication, topic data link control. First we move on to the functions of the data link layer. Our first one is data link control and media access. Data link control includes services of data link layer. First one is framing and flow and error control. This concept we have to be discussed. Before going to that one, we have to know about the layers of the OSI model. Physical layer, data layer, network layer, transport layer, session layer, presentation layer and application layer. Frames concept will come under the data link layer. Above the data link layer we have the network layer. Network layer we have to be discussed about the packets. Below layer is the physical layer that contains the physical structure such as wireless, cables, fiber or hubs. That concept will come under the physical layer. In data link layer, frames concept will be coming. With that we have to discuss about the switches and the bridges. In network layer, packets, for example IP packets. In transport layer, TCP and UDP, connection oriented and connection less oriented. Next, session layer, synchronization. Presentation layer, syntax layer. Application layer, for example HTTP and FTP. We can give that layer as an example for the application layer. Next, framing. The data link layer converts packets into the frame. The format is like this. First it contains the flag, header, trailer and again flag. It will take the data from the upper layer of variable number of characters. Topic we have to be discussed in this session is one is fixed size framing. The size of the frame will be fixed in that one. Variable size framing we have to be discussed two types in that one. One is character oriented approach and second one is the bit oriented approach. Character oriented approach we have the frame format is like this. We have to take the variable number of the character from the upper layer and then the process is continued in the character oriented protocol. And in this one we have to study about the byte stuffing and unstuffing. In byte stuffing it will take from the higher layer. We are adding extra 2 bits in order to unstuff the byte. For example, byte stuffing is a process of adding 1 extra byte whenever there is a flag or escape character in the text. Bit oriented protocol we have to use the bit pattern. Either it may be a 0 or 1. We have to take the data from the upper layer, that is the network layer. Variable number of the bits will be there. A bit frame is frame in a bit oriented protocol. A bit stuffing is a process of adding 1 extra 0 whenever 5 consecutive ones follow a 0 in the data, so that the receiver does not make a mistake the pattern 0 1 1 1 1 1 0 for the flag. See here in this example we have, if there is a 5 consecutive zeros once, we have to add 1 extra bit. So in this example, if you are taking the data from the upper layer, we have to be stuffed by either adding 0 to the 5 consecutive ones. In our example we are adding 2 extra bits after the 5 consecutive ones. Next, flow and error control. The most important responsibility of the data link layer are flow and error control. That are very important concept. How to control the flow of the data, how to overcome from the error is very important in the data link. Are the two main functions of the data link control. One is flow control, coordinates the amount of data that can be sent. Error control, error detection and correction. Next, flow control refers to the set of procedures used to restrict the amount of data that the sender can send before waiting for the acknowledgement. Error control is the data link layer is based on automatic repeat request, which is the retransmission of the data. Next we move on to the protocols. Now let us see how the data link layer can combine framing, flow control and error control in order to achieve the delivery of the data from one node to the another node. See, taxonomy of the protocols. For example, if you are discussing about the noiseless channel, we have to discuss about the simplest and the stop and the wait. For noisy channel, we have to discuss about the stop and wait ARQ, and go back N ARQ, selective repeat ARQ. For example, if you are discussing about the noiseless channel, let us first assume we have an ideal channel in which no frames are lost, duplicated or corrupted. We introduce two protocols for this type of the channel. Topic, simplest protocol, and second one is the stop and wait protocol. See, we have to get the data from the network layer, and we have to be perform operations in the data link layer, and that frames are sent into the physical layer. Again, from the receiver side, it will receive the frame at the physical layer, then the data link layer, and deliver the data to the receiver in the network layer. This is the simplest, or the design of the simplest protocol with no flow or the error control. See, a figure is given, shows an example of the communication using this protocol. It is very simple. The sender sends a sequence of the frames without even thinking about the receiver to the 3 frames. 3 events occurs at the sender side and 3 events at the receiver side. Note that the data frames are shown in the title tilted boxes. The height of the box defines the transmission time, difference between the first bit and the last bit in the frame. See here, in this example, we can see the request sender will send the frames, and the receiver will be receiving the data. Here we have to no need of waiting for the acknowledgement. Here we are directly sending the packets without thinking about the receiver. The frames are sent by the sender in a sequence order. Here in our example, we are sending 3 frames. The 3 events are occurred at the sender and 3 events occurred at the receiver side. The data frames are shown in the tilted boxes. The height of the box defines the transmission time. This concept will come under the stop and wait. This concept will come under the simplest protocol. And next one is the stop and wait. See, stop and wait, we have to get the same procedure, get the data from the and send the data and send the frame, again receive the frame in the same layer, and the data will be sent and acknowledgement will be returned. We can clearly find the solution by using this example. Figure shows an example of the communication using this protocol. It is very simple. The sender sends 1 frame and waits for the feedback from the receiver. When the acknowledgement receives, the sender sends the next frame. Note the transmission sending 2 frames in the protocols involves the sender in the 4 events, and the receiver has the 2 events. See here, the acknowledgement, we have to wait for the acknowledgement. For example, if you are sending the 2 requests, here we are having the 4 events. First we have to send the data and wait for the acknowledgement or the feedback. After receiving the acknowledgement, we are sending back another frame and we have received the acknowledgement. These things will this is the example for the stop and the wait protocol. Thank you.